All right, we're going to talk about doing operations with complex numbers. So adding them, subtracting them, multiplying them, not dividing because that can actually be a little bit tricky. Remember, a complex number has a real part. So a real number like 2, 3, a fraction, negative, any kind of normal number, let's say here. And then an imaginary part. That imaginary part will always include an I. Now, all numbers can be written as complex numbers. They just have a 0 for the imaginary part if they happen to be a real number. Anyway, let's go ahead and talk about how to perform some operations using complex numbers. So here we have some numbers that are actually just purely imaginary, 4i minus 2i. Throughout this, I'm going to be saying things like combining like terms and doing a lot of things in a similar manner to when we have variables. It's important to understand i's are not variables, they are a number, but a lot of the ways that we work with them are going to be similar. So we have 4i minus 2i, and it's going to work pretty much exactly the way you think. I'm just going to subtract 4 minus 2, which is 2i. If I have 4 i's, take away 2 i's, I'm going to be left with 2i. And that's our answer. It's that simple. Here for our second one, it's slightly more complicated. We have some real numbers and some imaginary numbers, or we could think about these as two complex numbers. But what I'm going to be doing here is sort of combining like terms. I'm going to be combining the real parts and the imaginary parts. So the i's. So I'm going to go ahead and start with the real part here. I have 10 minus 3. It's going to be 7. That's the real part of my answer. And then I have negative 8i. I'm going to treat this as a negative because there's a minus in front of it. Negative 8i plus 6i. So negative 8 plus 6 is negative 2i. And these two pieces together are my answer. My answer is a complex number. It has a real part and an imaginary part, 7 minus 2i. We can move on here. Now we have these two complex numbers with parentheses around them. So we have this complex number minus this complex number. The parentheses, particularly over here, are very important because I'm subtracting this entire quantity. I'm going to need to think about distributing this negative, this subtraction, to both parts of this complex number. So I'm actually going to rewrite this. It's negative 5 minus 2i. Then I distribute this negative here. This becomes minus 3. And then minus, that double negative there is actually going to change to plus 4i because I would be taking away a negative 4i. Instead, I can think about it as just adding. Now this looks a lot like the previous one. I'm going to simply do that idea of combining like terms. I'm going to combine the imaginary parts together, and I'm going to combine the real parts together. And I'll still have another complex number for my solution. So I have negative 5 minus 3. That gives me negative 8 for the real part. And then I have negative 2i plus 4i. That's going to be positive 2i. And a lot of 2 i's here. That's just a coincidence. Here our answer is, again, a complex number. Real part, imaginary part. All right, here we go. Hopefully you've watched the Powers of I video already, because we're going to need that when we multiply these together. So we have 3i times negative 2i. Again, a lot like variables, I can almost think about this as sort of like 3x times negative 2x. Now, I'm going to take it a step further than I would with these variables. With these variables, I would multiply the coefficients. 3 times negative 2 is negative 6. X times x is x squared. That's it. That's all I would do there. I have to take this one a step further than that because I is not a variable. It is a number. And when I raise it to a power, something happens. So here we do 3 times negative 2, we get negative 6. I times I gives us I squared. I squared, if you've watched the previous video, anytime we end up with I squared, we get negative 1. So this is really negative 6 times negative 1, which gives us a real number, positive 6. So that's really strange. When you multiply two imaginary numbers, these are purely imaginary, there's no real part with it. When I multiply those together, I ended up with 6, just a regular old real number. All right, the last one on this page. All right, I'm going to keep going with the multiplying. We're going to be multiplying this imaginary number here inside. We're going to be distributing it. So we distribute that. And again, it's a lot like these i's are variables. I'm going to treat them very similarly until I have to reconcile the exponents that I end up with. All right, negative 4i times 7 is negative 28i. And then negative 4i times positive 2i, that's going to be negative 8i squared. Now again, here's my problem, I squared. Anytime I end up with I squared, and this happens when we're multiplying, I have to do something with that. I have to change it into a negative 1 because that's the value of I squared. These are not just variables, these are real, actual, well, not real, they are actual numbers that we have to do something with. All right, so we have negative 28i minus 8 times, now this is a negative 1. I squared becomes negative 1. Right here, I can simplify that out a little bit. I have negative 8, negative 1, that becomes positive 8. And we could stop right there. That would, I mean, mostly be okay. But typically, we write complex numbers in the other order. We write the real part first, and then the imaginary part second. So 8 would go first. That's the real part, minus 28i. So I'm going to go ahead and do that because that's the way it would normally be done. Yep. All right. Just 2 more to look at here really quickly. They're going to take a bit longer, but it's the same ideas that we were working with. All right, we have 2 complex numbers, 5 minus 2i times, these are multiplied anytime we have parentheses like that, and this other complex number, negative 3 plus I. You could say that there's a little 1 there if we want to think about it like that. The coefficient is 1. I'm going to use the generic rectangle, or for Mr. Bechtel's students, the Bechtel box, to multiply this out. So I'm going to put one of my complex numbers on the top, one on the side. I really just need them on 2 sides. Some people put it on the bottom on the side. Doesn't really matter. So I'm going to do 5 minus 2i. I'm going to do negative 3 plus 1i. Again, I don't need this coefficient, but it doesn't hurt to have it there. It's particularly useful if it's negative. Keeps people honest. All right. So we're going to multiply. We get negative 15 here, 5 times 3. 5 times 1i is 5i. Negative 3 times negative 2i is positive 6i. Oh, no, silly me. I almost put an exponent there. I only have 1i. All right, here's where I'm going to get an exponent. Negative 2i times 1i is going to be negative 2i squared. Now we know that's not quite good enough, but I'm going to go ahead and take my answer out of the box first, and then I'll sort of deal with that. So I get negative 15 plus 5i plus 6i and minus 2i squared. Oh, you might get faster at this. You might be able to skip some steps here, but I'm going to go through it all. This is negative 1. This right here, I am going to think about this as just negative 1. Anytime I end up with I squared, that's what I need to do. I need to change that I squared into a negative 1 because that's the value of I squared. All right. Now, let's go ahead and multiply that. We get negative 15 plus 5i. All this is just coming down. And then here we have negative 2 times negative 1 is positive 2. So that I squared is gone now. Now it's really similar to some problems before, where we're just going to kind of combine like terms. We're going to put together the real parts. End up with negative 13, negative 15 plus 2. And then 5i plus 6i is positive 11i. So there we go. Awesome. And we're going to do one more multiplying example. Well, maybe I didn't leave that up there long enough. Negative 13 plus 11. Okay. We're going to do one more multiplication example. And this is really important because these two complex numbers are what's referred to as conjugates. You don't need to know that necessarily at this moment, but conjugates are really useful with complex numbers, and we're going to see why in a minute. But I know they're conjugates because they have the same real part, but one of them's plus, one's a minus. They have a positive real part and a positive imaginary part and a negative imaginary part. And when they get multiplied together, it's going to follow that difference of squares pattern that we learned about in the past. And that's going to be really great for us because we'll end up with a purely real number answer. Let's see how that happens. So again, I'm going to use my multiplication box, generic rectangle, Bechtel box, whatever your preferred term is. 8 4i, 8 minus 4i. Okay. And then I'm multiplying. Hopefully I have a good handle on this already. 64, negative 32, 32, negative 16i squared. There's that I squared again. We'll have to deal with that later. But this is the power. These ones right here, that's what's going to be awesome. You might be able to see it already. The negative 32i, positive 32i, those are just going to cancel out. They're going to become 0. Those i's go away. And this one, it's I squared. We already know that's going to go away too. So we are going to end up with 64 minus 16 times negative 1. I squared becomes negative 1. Let's take this further. 64. Negative 16 times negative 1 is actually positive 16. Add those together, and we get 80. A purely real number answer. That will always happen when you multiply things that are conjugates, which is very powerful when you're trying to actually do division of complex numbers. But we're not going to get into that right now.